Yeah, so let's start with this guesstimate. So today we are going to solve the question, estimate the Google Map storage. That is the question asked by the interviewer. So let me just start with some clarifying questions. Clarifying questions. So my first question uh, is um, what do we mean by the storage here? So please clarify into exactly what we're trying to solve. So the response, I'm assuming the storage we are referring here is the the storage occupied by the maps in by all the maps in Google Maps. So it is like, let's say, if I consider the world map, so all the data of all the world map, how much space is that going to occupy in the storage centers of Google? So that is the question we are trying to solve. The second question I'm going to ask is, uh, are we what is the demographic? Are we sorry? Are we thinking of all the Google Maps data or any country or city or region specific? So let's just assume that we are only calculating the Indian data. Okay. And so the third point is key uh, this app storage alpha also is um, any specific type of map I should focus on, like commercial maps or the one used by end users on Google Maps. So here we are considering only uh, the maps that are used by end users on app in India. Okay. Okay, and also I want to clarify that are we talking about the storage occupied by one device by Google Maps in the user's device, or the storage occupied by or by the maps data in Google database. So here we are talking about the second one, basically this one, the storage occupied by maps data in Google database. Okay. and any particular time frame we are talking about, or for the recent data 2.25. So it should be latest updated. Okay. So here I am assuming that we are estimating the satellite map data stored occupied occupied in database, including all the features like street view, street view, geographical features, routes, and etc. So uh, let me just take about 2 to 3 minutes and get get me an approach so that I'll let you know about my approach for it. So one more thing we need to clarify here is that we are calculating the satellite view of the structure of routes, or we are also going to estimate the data stored by each of the stores. Let's say if there is a grocery store on the Google Maps, so it also has these data about, let's say, reviews, its description, menu, and other things like that. So that is what we are thinking. So I'm assuming we are calculating all the aspects, and just as much as I can think of, I need to include it in the estimation. So, if the let's say, let me just take one more minute. So, as per my approach, so I'm going to use different range scale for the illustration. So, what my approach is going to look like is, um, there are multiple features in an Google Maps. So, if I'm considering Google Maps, so it usually have, let's say it have, first one is, it contains coordinates of all the points on the map. Coordinates include latitudes and longitudes value. Second one is, um, so that is like, so it contains two data points. Each point on the map of India has a latitude and longitude associated, and user can navigate to that point using that Google Maps. Second one is, each there is multiple routes, so all the travelable routes are having routes information. So each route, street, highway name. So the third thing is, all the stores. So if there is a stores, so stores, outlets, information. This includes, these all these stores include information about the description, name, description, description, images including menu items as well, reviews, and then other things that also, let's say, contact information, and that is etc. Um, um, the other thing like that is geographical information. So information like, let's say, it includes mountains, rivers, and plateaus, something like that, ridges, oceans, beaches, so something like that. So it having geographical information of all that. And Google Maps has multiple types of views. Let's say if the default view is the route view. Second one is the satellite view, which includes the information about the congestion on the road. So that is the information about the congestion of traffic on routes. So that is also a data point which we have on routes. So it the this data is stored like that. It's usually it is if it appears blue, so that is the usual ETA. It shows the usual ETA, and if it's colored with yellow or orange, then it depicts delayed delayed ETA. So estimated time of arrival. So when okay, so these are the all the data points I'm here considering for all these. Okay, so after considering this, let's say if I don't have the data about the area of India map. So if I have to calculate the area of Indian India, so I don't have the data about area of India data. So if I'm considering, I have an as rough understanding of area of Haryana. So assuming the area of Haryana to be around 200 kilometers wide and 200 kilometers. Uh, so it is like assuming it to be a 200 kilometer by 200 kilometer square, which comes around to be 40,000 something, 40,000 kilometers square. Okay, so assuming that we have 29 states of 29 states. Okay, so some states are larger than Haryana, some states are very much smaller than um, Haryana. So if we average it out, so it would be like we can accommodate around 250 Haryana states in India. It's an assumption. So it is going to be the area of India is going to be 25 times 40,000 kilometers square. That will come around 1 lakh. So 10 lakhs, sorry, 10 lakhs. Mm, 10 lakhs kilometers square. So um, assuming that each point on the map has a coordinate of latitude and longitude. So let me just clear this. So let's start with this calculation. So if each have a coordinates, each point have a coordinate of, let's say, so it 10 lakhs is the area of latitude and longitude. So each latitude and longitude is it's in degrees. Let's say 22 degrees, 20 degrees, and 30 minutes and 30 seconds. So it will be. I'm assuming it will be occupying a 8-bit space. So each point will be occupying 8 bits of latitude space and 8 bits of longitude. So it will come around 16 bits, 16 bits of data per coordinate. And if I'm assuming that it is 10 lakhs kilometers square of area of India, and assuming that 1 meter square of area of India will have one coordinate, it is my assumption. So 1 meter square of area on the Indian Indian plane it will reflect a coordinate. So that will be like um 10 lakhs, first of all, 10 lakhs kilometer square equals to 1 kilometer has 1000 meters. So it would be like it is 1 2 3 4 5 6 10 to the power 6 6 times 1 2 3 to the power 2. So that would become around 10 to the power 12 meter square of area. And if each meter square of area is going to have, so that is will be around 10 to the power 12 coordinates, and each coordinate is occupying the space of 16 bits per coordinate, then um, it will have around 16 into 16 times the 10 to the power 12 bits of space. So this is the data of the only coordinates. Also, let's say if you have the second point, which have route, street, and highway name data. So we're considering routes, highway. These are like the permanent pathways to travel. So if I'm considering an area of, let's say, this is an area of 1 kilometer by 1 kilometer, then there will be routes in it. There will be multiple things in it. Let's say if there is houses in here, geographical features in here, and then will be the routes. So um, so if I'm assuming only each highway and route will have data like name of the route, an area or like extremities associated with it of that, a name and area of extremities of that route. So each name will have So one thing to modify here is that each coordinate will have something like 64 bits of floating number. So 64 bits is occupied by one floating number, so it will be like 128 bits per coordinate. So correcting it here would be around 128 times this one. So each name, so one character takes around 8 bits of space. So if we are assuming that each name of a root will be approximately around 10 characters, it will be around 80 bits per name. And in the area and extremities, if I'm assuming the end coordinates and the starting coordinates is mentioned, so it would be around 64 bits per coordinate of starting and ending. So it would be around 128 bits as well. So this, if I'm assuming that 1 kilometer square of area will have 1 kilometer square of area will definitely will have approximately 1% will have one root, average one root. So it is like 1 kilometer around for 1 kilometer square of area will have one root, will have at least one root. So it would be if it's 10 lakhs kilometer square, so it would be around 128 plus 80. Okay. So that would be around 28 plus 80 is 208. 208 and needs to power 6 bits of storage. So that is for the wave. Third point is the stores and outlets. So similarly, each store each store would be having a name, description, name, description, reviews with each review will have stars, text reviews, and images. Images, reviews, and images uploaded by the response outlet. So that is the for each store, the coordinates is already covered here. So we're not going to include the name of the storage acquired by the coordinate of that store. So here, if I'm assuming the each name will have similarly 80 bits per the name, if it's around 10 characters, and the description may be around, let's say if it's a two-liner description, two-liner may have 20 words. So 20 to 10 to 20 words. So if I'm assuming 10 words, 10 to 20, 20, 20 words into times 5 factors. So 50, 20, 20 words, and then per word there are 5 factors. So 100 bits, 100 into 8. So it will be around 800 bits. So reviews, each review, if I'm assuming that a store will be having for an average around 20 to 30 reviews. So reviews may range from thousands up to lakhs reviews as well. So if I'm assuming that 1,000 reviews on an average, 100 reviews on an average per store. So each review will have a star associated with it, which is like a floating number. So each floating number is occupying 64-bit of storage, 64-bit, and similarly the text is going to occupy around 400 bits, and an image. For an approximation, let's take an image size of 1 MB per image, and here as well. So this is like, this is for one review, and images, if I'm assuming each restaurant will have at least two images uploaded by the store owner, 2 to 3 images, so 2 to 3 to like 3 MBs of storage occupied by the images uploaded by the store owner. So coming back to the calculation, so each the reviews are, let's say, 100 reviews per store, and if we are similarly, if we assume that a 1 kilometer square of area, a 1 kilometer square of any area, 1 kilometer of let's if I assume 1 kilometer square, it will be around that. Kilometer of square of area will have around, so each, sorry, one, we don't, we usually take 1 kilometer square of area. If we assume that 10 meters by 10 meters, so 10 meters, if we, there are multiple types of, it depends on the region as well. So there will be things like highly congested urban areas and rural areas. So if we assume urban areas, so the urban areas will be having a high density of stores per uh, 1 kilometer square. So it will be around 10 meters is that much wide. So if I'm assuming that 100 meters, 100 meters square in this as well, there will be two areas, be highly congested. It will be like um, highly congested, so high density. So high density will have one store per 100 meter square area, and low density will have one store per 1 kilometer square. It will be a low to medium density. Where I'm assuming 1 store per 1 kilometer square area. So if um, urban areas we have 30% of Indian subcontinent, and rural areas we have 70%. So 70% of one to 10 lakhs comes around 7 lakhs. So everywhere it will be around 3 lakhs. So lakh kilometer square area. So if I'm considering the high density to be around 50%, so 50% will be around 150, 1 lakh 50,000 kilometers square of area. And here one presuming 1 lakh 50,000 kilometers square of area also low to medium density. Here all this 7 lakh is low to medium density. So 1 kilometer square. So if it is around one store per 100 meter square, so around one store per meter square. So it will be around one store per 10 raised to power minus, it will be around 100 divided by 1000 square. It will come around 0.06. It will be 0.01. So if it's a 100 meter, if 100 meter square of area is having this much, so 1 meter square will have 1 upon 100 stores. 1 मीटर स्क्वायर इतना आ रहा है एंड 1 किलोमीटर स्क्वायर में 1 मीटर स्क्वायर is having this much. So 1 kilometer square have 10 raised to कितना मीटर स्क्वायर each kilometer square of area will have around will have around 10,000 stores for each kilometer square area. 10,000 stores. So similarly, if all the data combined, 10,000 stores per kilometer square, so 1,50,000 kilometer square of area times 10,000 stores per kilometer square of area. That is going to come around 15 times 10 is to power 8 stores. This was number of stores on the Google Maps. And similarly, taking this match, so it will say similarly to 15 times 10 raised to power 4 stores, where it is around 7 times raised to power. This much number of stores we have on the data. To take it, it is coming around too much. It is coming around too much. So if we take 1000 square meter and if we divide it by this much, so that would be less, around 1011, around 1000, and if you put here as well. So if I am calculating here the amount of this this data comes around 80 bits, 80, 800, taken around 1000. Let's take an average of 1000 bits of data. And if it is having 100 reviews, so 100 reviews times it could be, if one review, so review it has having around, each review is having 400, 500, let's say 500 bits and 1 MB. So another, we're taking around 1000 bits and 3 MB. So 100 reviews per store as well. So 100 reviews would be come around 100 times this. So 100 MBs, 100 times this is going to be 500. 50,000 plus 100 MB. So we're taking assumption. So it would be approximately around 50,000 bits per plus 5 MB per store. Okay. So coming back to our final number, will come around 1585000 approximately. We can take it around, let's say 1600. 16 times 10 raised to power 7 bits of data. Stores is the number of stores. And if we are taking 50,000 bits in plus 5 MBs, 50,000 bits. So 50,000 bits into 16 times 10 raised to power 7. That would be around 5 times 16, 8 times 10 raised to power 12 bits plus taking all these numbers back. So here we have this. So 128 times 10 raised to power 12 bits. Then we have 208 times 10 raised to power 6 bits. Now we have 8 into 10 raised to power 12 bits. Now we also have 80 times 10 raised to power 7 MBs of data. So adding all this with this part, it will come around total bits will be around. So I'm assuming this much as negligible as it is around half of that for this one. So it would be approximately around 130, 140, sorry. So 140 times 10 raised to power 12 bits. And if let me just do it. So we know that 1 KB is equal to 1024 bits bytes. So if it calculating in bits, so it will be around this much bits, and 1 MB is around 1 to 24 times KBs. So It will come around 1024 squared times 8 bits. So that would be around 1024 times 1024 times 8. So this 1 MB comes around 8 3 4 2 608 bits. Okay. So here we have the total bits and here we have 1 MB. So converting this much into bits. So total data part 1 data 1 is comes around 140 times 10 raised to the power 12 divided by 838 So it comes around 166,8930 MBs, and it is around 80 MBs. So adding this much to it comes around 801,668,930 MBs. And if we convert them into GBs, so it would be divided by 1024. So that would come around 782,879 GBs of data. So this is our final answer. Thank you.